All right, this is section 4.3, solving inequalities using multiplication or division. We're going to treat this just like we normally treat a normal equation, and we're going to solve for the variable just like we did last time via SADMAP. However, there is one extra step. If you multiply or divide by a negative, pop goes a symbol. Do it again. If you multiply or divide by a negative, pop goes a symbol. If you multiply or divide by a negative, pop goes a symbol. If you multiply or divide by a negative, pop goes a symbol. Hopefully that's getting annoying and getting stuck in your head, because this is a little extra step when it comes to inequalities. What I actually mean is to turn it around. And I'll just give you a little bit of an example. So if I have negative 4y is less than 2, all right, I'm going to divide by negative 4 on both sides, and I get y, and this side would become negative 1/2. What I'm going to do is literally turn it around, all right? And there is a reason for that, and I'll show you why in just a minute. But that's what I mean when I say if you multiply or divide by a negative, pop goes a symbol. All right, now, with that being said, let's do a couple of problems here together. So, yeah. All right, so first one, we have 6n is less than 90. Well, just like before we do SADMAP, we're just going to divide by 6, and we're going to do that on both sides. The 6 cancels out, and I get n is less than, and let's find out what 90 divided by 6 is. 90 divided by 6 gives me 15. And now it's just a matter of graphing it. I'm going to put 15 right here. And since this right here is just less than, it means it's an open circle. And because n is less than 15, I'm going to draw my line all the way towards the left. I'm done. All right, let's do number 2 together. I have x divided by 4 is less than or equal to a negative 18. All right, so in order to get rid of a divide by 4, I use the SADMAP rules. I'm working backwards. I'm going to multiply this entire side by 4. And what I do to one side, I must do to the other side. This cancels out and leaves me with x. And now look at this. I have a negative on this side, but because I'm multiplying by a positive 4, I don't have to worry about singing my song right now. So my symbol does not change. And I can go negative 18 times 4, and I get negative 72. Now I'm going to do the same thing. Because this says it equals 2, I'm going to have a closed circle at negative 72. Whoops, that's not very good, Mr. Lewis. Try that again. Negative 72. And it says that x is less than that number, so it means that I am going to go to the left. All right, let's do this next one. This time I have a negative 20 times t is greater than or negative 80. All right, so I'm going to show you the correct way of doing this. I'm going to divide by a negative 20, and I'm going to do it on both sides. And this goes back to that song, if you multiply or divide by a negative, pop goes a symbol. So I'm going to cancel out my negative 20s. I have t, and the symbol goes pop and switches around. And negative 80 divided by negative 20 is a 4. All right? And so now that I read this, I have t is less than 4, so open circle, add 4, and then since it's less than, I know this is the case. Now, let me show you what would have happened if I didn't switch the symbol around. I do all the work, and instead, I forget to switch the symbol. All right? So if I did that, that would actually give me an incorrect graph that looks like this. Okay? So what we would have to do is see if the number correct. So in this particular one, we know that negative 5 is less than, not negative 5, but let's do an easier one. We know the number 3 is less than 4. So we can take this 3 and plug it into our original equation, or inequality, Negative 20 times 3 is greater than or equal to 80. And when I work that out, I have negative 60 is greater than negative 80. Is that true? Yes, it is. So this solution works. But let's try this. If I choose the number 5 instead, I put this back into my original inequality. Negative 20 times 5 is greater than negative 80. Negative 100 is greater than negative 80. Is this true? No, it is not. So that's the reason why we have to pop that symbol, because if we don't, we're going to get a false answer. Notice what I said. When I didn't pop the symbol, it gave me that this direction. All the numbers bigger than 4 are a false answer. So we have to pop that symbol when we are dividing by a negative number. All right, let's see if I got another one here. I'm gonna do 7 with you, okay, just to kind of show this. So this time I have a negative r divided by 4 is less than or equal to a negative 10. Well, I want to get rid of that negative in that 4, so I'm gonna multiply the whole thing by negative 4, and I'm gonna do that on both sides. The negative 4 cancels out, and that leaves me with just r. And negative 10 times a negative 4, and this is multiplication, is going to give me a positive 40. And since I multiplied by a negative number when I had to do this, when I was doing my SEDMAP, and I multiplied by a negative number, when I multiply or divide by a negative, pop goes the symbol. So my symbol changes, all right? It's just one of those rules. Now that I have that, I can put a dot, a closed circle at 40, and r is greater than that, so I can do this. And I can prove to make sure that this is true. I know that, let's say 80 is a number bigger than 40, and I can plug it in there. 80 divided by a negative 4 is less than or equal to negative 10. So let's find out if that's the case. We have 80 divided by a negative 4 gives me negative 20. Is this a true statement? Yes, it is. So this is correct. So remember, when you multiply or divide by a negative, pop goes the symbol. All right, so what I want you to try now is, why don't you try 4, 5, 6, 8, and 9 on your own, and come back and see how you did. All right, so if you can look at your answers right here, I'm not going to read them out to you. You got 5, 6, 3, 5, 6, 8, and 9. Please look at your answers and check them. And if you have any problems, you know where to find me. Let's talk about number 10. It says, to win a game, you need at least 45 points. Each question is worth 3 points. Write and solve the inequality that represents the number of questions you need to answer correctly to win this game. All right, so you know right now that each question is worth 3 points. Let's just concentrate just on that. So how many points or how many questions did you get? You don't know, but we know this. It's 3 points per question, and we can just say 3x, all right? That means that for every question I get, I'm going to get 3 points, all right? Now, this next piece, it says to win a game, you need at least 45. So what does that mean, at least 45? Well, go back all the way to 4.1, and this was that note. What I told you, this one says is at most, this says is at least, and because it says is at least, we need, need at least, we're using this symbol, the greater than or equal to. Here's the reason why. You are trying to make at least 45. You can't, if you make 44, then you didn't win. If you make 43, you didn't win. But if you make a 45, or if you make 46 and so forth, you did win. Now that we've done that, we just simply solve, and we can divide by 3 on both sides, and x is greater than or equal to 15. Here's the thing. We didn't have to pop the symbol because it was a positive number. So I need to win at least 15 questions. All right, so I need at least, keep spell, now let's stop the thing, at least 15 questions to win the game. All right, and that's it for this video. And next video, we're going to be doing a combination of adding, subtracting, multiplying, dividing, and we are done. And I will see you in the next video. Bye-bye.